Hello, my name's Charlie Nicklin. This is video 4 in our 5-part series on achieving professional registration. You can see a full breakdown of the content of each video at the start of video 1, along with an overview of the whole process. In this video, I'll cover the individual route process, which is there for those that do not have those prerequisite qualifications discussed in video 2. So how do you actually complete an individual route assessment? Well, let's take a look. As I've mentioned in the video covering the application process, the individual route is there for those who do not possess either accredited or recognised qualifications, or have qualifications for a lower registration grade, or don't hold any formal academic qualifications at all. The individual route assessment is an extra step at the start of the process where our assessors seek to establish the learning that you've acquired, whether they are formal qualifications in a different subject area, employment training, self-directed learning or experiential learning. This process is the same for Eng Tech through to Chartered Engineer and does require this extra document completing. This assessment is all about engineering knowledge and learning, not competence. The assessment allows you to provide evidence of what you have done through your career to gain the underpinning knowledge and understanding of engineering to a similar level to someone who has received formal training via an accredited programme. There are 5 key areas that are explored: science, maths and engineering principles, engineering analysis, which includes problem analysis, analytical tools and techniques, technical literature, design and innovation, which covers design, integrated and systems approaches, the engineering society, covering sustainability, ethics, risk, security, equality, diversity and inclusion. Engineering practice, which covers practical and workshop skills. Materials equipment, technologies and processes. Quality management, engineering and project management, teamwork, communication, lifelong learning and CPD. The knowledge and learning needed for Eng Tech is of course very different to that required of a CEng. As we've discussed in video 1 and 2, the entry requirement for Eng Tech is level 3 on the English qualification framework. So that means the knowledge and learning expectation will be at the vocational level, which is taught via qualifications like BTEC national diplomas, the modern apprenticeship standards and T-levels. For IAgrE, it's at level 6, so a bachelor's degree level, and consequently a higher level of theoretical knowledge. And then for CEng, it's level 7, which is taught via master's degrees, so much more maths, science, theoretical techniques applied to complex problems. Our assessment form show all these 18 learning outcomes broken down in detail, so you know exactly what they mean. If we look at the Chartered Engineer and the engineering analysis, analytical tools and techniques, this requires the individual to be able to select and apply appropriate computational and analytical techniques to model complex problems, discussing the limitations of the techniques employed. What our assessors will be looking for is how you can evidence that you meet this requirement. What we'll do now is look at a few examples for the different registration grades and learning outcomes. So if we take the engineering analysis, but let's apply it to an Eng Tech application. The requirement for analytical tools and techniques for an Eng Tech is to be able to use appropriate computational and analytical techniques to solve well-defined problems. Scenarios of this could be a field service technician diagnosing a problem with a control system on a complex machine, such as a combine harvester. The technician will need to go through a logical problem-solving routine by utilising the right diagnostic tools and equipment to investigate and resolve the issue. A good knowledge and understanding of the components used and how they work together in a system is essential before any diagnostic work can be undertaken. Another example could be a technician in a manufacturer's experimental department setting up a test rig to simulate real-life conditions. The test rig will need to measure loads during its operation. For the technician to be able to accumulate this data, they need a good knowledge and understanding of methods to be able to record and then process the data into usable information. What our assessors are looking for is how you can evidence that you've gained this underpinning knowledge and understanding on how to approach these types of tasks. This could be achieved in a number of ways. You may have completed an external training course or module. You could have received some in-house training via your company. You may have done this as part of another qualification which wasn't recognised. In this case, you can just show the programme transcript. You may have learnt it yourself by doing some self-directed learning or CPD. You may have been instructed on how to do it by a qualified, competent person. Or you have simply learnt it as you've gone along by experimenting. As you can see, there are a number of ways you can evidence how you've gained this knowledge and understanding to meet the learning outcome. You just need to think about what you've done in your career to have achieved it. Let's have a look at a second example, now for an incorporated engineer, and this time we'll look at engineering practice, and we'll choose the engineering and project management attribute. Under this learning outcome, it states the individual needs to be able to apply knowledge of engineering management, principles, commercial context, project management, and relevant legal matters. A scenario of this could be an engineering product support manager rolling out a training event for technical staff in dealerships. The activity will require a project plan creating in the form of a Gantt chart, in which the task duration and timing needs to be populated. This then allows the project's critical path analysis to be completed and the resource levelling achieved to end up with a realistic programme. Before such an activity could be undertaken, the individual would need to know the knowledge and understanding on how to create plans, the theory behind planning, the use of techniques like critical path analysis. Once the programme has commenced, the project needs to be tracked and progress reported to the various stakeholders. Unforeseen issues may arise, requiring replanning and communicating to all concerned. What our assessors are looking for is how you can evidence that you've gained this underpinning knowledge and understanding on how to approach this type of task before you gain the competence to put it into action. It's back to the same thing we discussed before. Did you complete some form of project management training like PRINCE? Maybe your company gave you an in-house project management course. You may have done this as part of another qualification, which didn't even have to be engineering specific. Just show the programme or syllabus transcript. You may have worked as part of a planning team and picked it up from your managers. Or you have simply learnt it as you've gone along by experimenting. As before, there are a number of ways you can evidence how you gain this knowledge and understanding to meet the learning outcome. Finally, let's have a look at one for a chartered engineer. We'll pick the engineer and society and we'll go for the risk attribute. Under this learning objective, it states the individual needs to be able to use a risk management process to identify, evaluate and mitigate risks associated with a particular project or activity. A scenario of this could be a senior researcher working on field trials who oversees technical research staff conducting field experiments. The work might involve operating machinery in remote areas or close proximity of people. If you think about the theoretical tools and techniques that are needed to carry out these types of activities safely, not only for the people involved, but also the environmental effects, you would need to produce things like method statements, carry out hazard analysis, risk assessments. How would you mitigate the risks? How much risk is acceptable? What are the legalities? These are all tools and techniques that you need to have acquired knowledge and understanding in before you ever try to put them into practice. So again, how do you prove that you've acquired this knowledge of how and where to use these techniques? It's back to the same things I've discussed previously. You need to go back through your career and education and provide our assessors with where you have acquired this underpinning knowledge and learning. In all cases, and for all the attributes, you will likely have to draw from a number of different sources to meet each one. If you have an unaccredited or unrecognised qualification, it may be as simple as stating under each of the learning outcomes that it was covered under Module X and Y of my qualification. If you have no qualifications, then the process is likely to be much more involved, as you will need to relate it back to your career activities. Once you have completed the documentation, it's sent to us here at IAgrE, and we send it out to 2 assessors for review. In some cases, we may need to conduct an interview to go through in more detail, which we'll advise at the time. When the process is completed and approved, it means we've formally accepted your knowledge and learning meets the entry requirements for the registration level you're applying for. The process is then as described in video 2, how to complete an application, where you will go through the assessment of competence. Okay, so now you know what we're looking for in an individual route assessment. Achieving registration through this route is a real milestone as it formally recognises what you've achieved through your career. If you have any questions, then get in touch with us at membership@iagree.org or give us a call on 01234 750 876. Thank you. Bye-bye.